In the last session, we have seen the types of rectifier. So types of rectifier are nothing but half wave rectifier and full wave rectifier. In full wave rectifier, again it is converted into two types. First one is a center tap transformer rectifier and second one is a bridge rectifier. In the last session, we have covered half wave rectifier. Half wave rectifier, why the name half wave rectifier? Because conduction takes place only during one half cycle of the AC supply. Therefore, we called it as a half wave rectifier. In that, the summary point are nothing but when diode is in forward bias, then it comes into the conduction, means it acts as a closed switch. Therefore, we are getting output across the load resistance. A second point is when diode is in reverse bias, it acts as a open switch. Therefore, we are not getting any output across the load resistance. That is nothing but V0 is equal to 0. Now, full wave rectifier. Types of full wave rectifier are nothing but center tap transformer rectifier and bridge rectifier. In that, firstly, we will see center tap transformer rectifier. So this is nothing but the circuit diagram of center tap transformer rectifier. Firstly, we will see which are the different components that are required for designing of the center tap transformer full wave rectifier. Single phase 230 volt AC supply is required. Then center tap step down transformer is required, that is T1, two diodes D1 and D2 and load resistance RL. These are the components required for designing of the center tap transformer rectifier. Here, as its name indicates, center tap means on secondary tappings are taken. Due to that tappings, a secondary voltage is consist of two parts. So for our sake of convenience, we have considered first part is a A0 and second part is a B0. Means whatever the voltage induced at secondary side, that is nothing but VA0 and VB0. Then we will see in detail positive half cycle operation and negative half cycle operation. In that we will see the operation of full wave rectifier for the positive half cycle. Here positive half cycle consists of again single phase 230 volt supply, step down center tap transformer, diode D1 D2 and load resistance. So for our sake of simplicity, here we have considered the polarities as plus, plus and minus. Means here upper point is A, middle center point is O and lower point is B. So A is positive and B is negative as we considered. When A is positive means this positive supply is connected to anode and lower negative supply is connected to the cathode. In same way, we have already given the polarity for the B also. B is negative, means negative is connected to the anode and positive is connected to the cathode. So already we know the concept. When external positive supply is connected to anode and external negative supply is connected to cathode, at that time diode comes into the conduction, means forward bias takes place. And when external supplies negative point is connected to anode and positive point is connected to cathode, at that time diode goes into the reverse bias condition. So according to that theory, here we will say that due to A is positive with respect to B, diode D1 is in on state, means it is a forward bias, therefore it acts as a closed switch. Therefore load current starts to flow from point A towards D, towards load resistance, and it come back to the O point. In same way, if we consider point B as a negative, then here a negative point is connected to anode and positive point is connected to cathode. Therefore diode D2 is in off state. So we will say that for the operation of positive half cycle, diode D1 is in on state, which will give the output for the positive half cycle, and this output is equivalent to the secondary induced voltage VA0. In same way, we will proceed for the negative half cycle. Here, we just change the polarities of the particular induced voltages. So here we have considered negative point, negative point and positive point. These are the polarities of the secondary induced voltages. So A is negative with respect to B, we will say that, or also we can say that B is positive with respect to A. So we will check which diode comes into the conduction and which diode doesn't come in conduction, or which diode is in off state. So here a negative point is connected to anode. So we will say that, we will easily say that diode D1 is in off state. We will also check for the B point. Here a B is positive, so positive point is connected to anode, negative point is connected to cathode. So we will say that our diode D2 is in forward bias state, therefore it comes into the conduction, it acts as a closed switch, therefore we are getting output across the load resistance. We will see how the flow of the load current. So load current starts to flow from point B, then D, through load resistance it will come back to the point A. Therefore in the negative half cycle we are getting the output. Next point, these are the waveforms of the full wave rectifier with center tapped transformer. Here firstly, we will say that first deals with VA0, means secondary induced voltage VA0, and second waveform is nothing but secondary induced voltage VB0. Here a key point is that voltage induced at the secondary is equal and opposite to each other, means there is a 180-degree phase shift between each other. So here in the positive half cycle we are getting VA0, secondary voltage VA0 in this manner, and same way secondary voltage is VB0, which is equal but opposite to the VA0. Then next point is conducting diodes. Already we have seen in positive half cycle diode D1 is in conduction and D2 is in off state. A positive half cycle is nothing but a 0 to pi cycle. In same way pi to 2 pi, this is a negative cycle. In this negative cycle a diode D2 comes into the conduction. Same operation repeats itself. So diode current ID1 indicate this particular portion. D1 deals with a positive half cycle. Diode current ID2, we know that it deals with a negative half cycle. So we are getting in pi to 2 pi cycle. So next important one, load current IL0 and load current IL0 and load voltage VL. Here load is purely resistive, therefore shape of the load current and load voltage is same, only there is change in the amplitude a little bit. So first here load current IL0 and second one load voltage VL. So we will make a summary for the center tap transformer rectifier in such a way that during positive half cycle, means in 0 to pi cycle, diode D1 is on, means it acts as a closed switch. Also we will say that it is in forward bias state. And diode D2 is in off state, means it acts as open switch, means it goes into the reverse bias state. Output is available across the load resistance, that is V0, or also we called it as a load voltage is equal to the induced voltage VA0. During negative half cycle, means in pi to 2 pi, diode D1 is in off state, means it acts as open switch due to reverse biasing of the diode D1, and diode D2 is in on state, means it acts as a closed switch due to forward biasing of the diode D2. During this process, output is available across the load resistance. We will say that it is a V0 or VL equals to the VB0, means we will say that in full wave rectifier we are getting output in both positive half cycle as well as the negative half cycle. Now we will see center tapped transformer rectifier with filter. We will see which are the different components required for designing a full wave rectifier with capacitor filter. Single phase 230-volt AC supply is required. Step down center tap transformer is required. Two diodes are required. One capacitor is required and one load resistance is required. We will see the load voltage waveform of full wave rectifier with the filter. So with the help of this capacitor, we are able to reduce the ripple content from the output of the rectifier. If ripple content will get removed, then we will get a pure DC supply. That is nothing but the filtration will takes place. So here we will see how this waveform will get drawn. Firstly, we have to draw a dotted lines from 0 to pi as well as from pi to 2 pi. After that, This particular waveform is divided into different sections that are nothing but 0 to A to B to C, and C to D. What is the actual operation? We will see. Initially, voltage on the capacitor is considered as a 0. After that, from 0 to A portion indicate the charging of the capacitor. How the capacitor will get charged? We will see. When A is positive, at that time our diode D1 comes into the conduction, means diode is in forward bias state. This forward biased diode D1 will charge the capacitor up to the peak value. So 0 to A indicate charging of the capacitor. At point A, Vc becomes equal to the Vm, means capacitor will get charged up to the peak value. After the point A, this dotted line indicate that there is reduction in the output of the voltage will takes place. Therefore, a D1 which is in the conduction will goes into the reverse bias state. Okay, therefore the discharging of the capacitor will takes place in this particular portion A to B, means we will say that in the portion 0 to A charging of the capacitor will takes place with the help of diode D1. Therefore, we will say that diode D1 is in on state, and in the portion A to B both the D1 and D2 diodes are in the off state. Now we are moving towards the negative cycle. In the negative cycle, we know that diode D2 is in forward bias state, means it is in conduction. Therefore, again our capacitor will get charged, means portion B to C indicate the charging of the capacitor. Again here at point C, capacitor voltage becomes equal to the Vm, means peak voltage. But after this point, this C to D portion indicate the discharging of the capacitor. Discharging of the capacitor will takes place due to Vc becomes greater than the instantaneous secondary voltage. Due to this, our diode D2 goes into the reverse bias. So, in the portion B to C, a diode D2 is on state, and in the portion C to D, both the diodes D1 and D2 are in the off state. This is all about the load voltage waveform of the full wave rectifier with the filter.